In this video, we will be discussing about worksheet 4, Newton's second law and component forces. Question number 1. A roller coaster car, 300 kg with passengers, accelerate down a 65-degree hill. We'll assume that friction is small enough it can be ignored. Draw a force diagram for the system of car and riders. So guys, in this case, roller coaster, this card, we're gonna shrink it to a dot. Remember that always downward there is a force acting on it, is called gravitational force, and there is a normal force acts on the card also perpendicular to the surface or perpendicular to the hill. So right now let's try to do that. So I am going to draw a dot here, and that dot represents the roller coaster. So we say that there is a force of gravity downward, okay, and when we think about this is like a hill, and there is a normal force upward, okay. So let me also draw this part like that. Okay, if I want to show the angle, what is the angle here? How can I show it? So if this angle is 65, then when you think about you draw the force of gravity downward, then this angle should be 25. Then this angle should be 65. So this angle is 65. Okay, now we can show what is the question says. Draw a force diagram. Yes, we draw that. Okay, determine the value of the component of the gravitational force parallel to the hill. So look at this here. In this case, in this force diagram, we can draw the component of the force of gravity this way and this way. Okay, so there are components of the force of gravity, this one and this one, but the question asks find the force component of the gravitational force parallel to the hill. So then I need to find this one, right? So firstly let's calculate the mg. Okay, I'm sorry, force of gravity. Remember the equation for that, m times g. Okay, so what was the mass is 300. Okay, 300 kilogram times 10 meter over second square. That will give you answer 3000 Newton. Okay, so 3000 Newton. In order to find the component, this component parallel to this is, if you look at this is the cosine, right? This side is cosine and this side is sine. Okay, this is sine. So sine 65 times 3000 Newton will give you the component. Okay, so let's do the calculation. So 65 sine, this is the sine 65, which is 0.8268 times 3000, that will give you 2480.5 Newton. So that is the parallel component of the gravitational force. Okay. Okay, so right now let's find what is the acceleration of the, okay, let me move it up. So what is the acceleration of the roller coaster down the hill? So at this time, I'm gonna use the force parallel to the hill, which is this one. I'm gonna use this one, and mass of the roller coaster, and I'm gonna find the acceleration. Okay, so right now let's do that. Let me write which equation I'm going to use. So we are using net force equals mass times acceleration. So we know the net force is 2480.5 Newton equals mass is 300 kilogram times acceleration, divide both sides with 300 kilogram, and 300 kilogram cancel each other, and then let's put this in calculator. 2480.5 divided by 300, that will give you acceleration will be 8.3 meter over second square. Okay, so that roller coaster will have that acceleration. Okay, now let's move on to the other question. Okay, if they are traveling 4 meters per second at the time shown in the picture, how fast will they be traveling at the end of the straight stretch 20 meters later? So initial velocity will be 4 meters over second, and the question asks what is the final velocity, and the question also give delta x, which is 20 meters. Okay, acceleration we already got it from previous question, which is 8.3 meter over second square. Okay, so which equation we can use? So we have this. Let me write all the equation and let's decide which equation we can use. I think that is the equation, the initial delta x equals 1/2 delta t squared plus v initial times delta t, and the final square equals 2a delta x plus v initial square. Okay. Okay, now we know the delta x. Okay, let's see if we can use this one or not. We are trying to find v final. Okay, so let's look at this one. V final we are trying to find. Acceleration we know. Delta t we don't know. So there are two unknown if we use this equation. So let's look at this one. V final we don't know. Acceleration we know. Delta x we know. Initial velocity we know. Yeah. So we can use this equation. So let's plug in here. So v final square equals 2 times 8.3. Let me write the unit to meters per second square times delta x is 20 meters plus v initial is 4 meters per second square. Okay, now rest of them is just math we need to solve. Okay, the final square equals, so 2 times 8.3 times 20 will be 830 meter square over second square plus 4 square is 16 meter square over second square. So right now let's add them together. Okay, we have the final square equals 846 meter square over second square. Let's take the square root of the both sides. Then we will have a v final equals 29 meter over second. So after 20 meters later, that's going to be the final velocity.